New generation systems based on biogold production reactors. Space telescope golden mirrors. Diagnostic imaging and treatment of cancer tumors. Laser set and mesotherapy, HIFU therapy, filler and Botox. Cerebrovascular clips, angioplasty stent and orthopedic prosthesis. Spacecraft and satellite bodies. New generation of brain memory prostheses.
It is the first time in the world that we have been able to create a biologically advanced reactor system capable of producing biogold. The system has several proprietary products in the medical field, industry, and aerospace. A system based on degradation of plastic waste has been used to provide energy for this system. Plastic turned into monomers in less than 14 hours in this reactor. It is the quickest degradation process of plastic in the world. Several invitation competitions were won with this project, as well as an award from the World Institute for Pattern Analysis. Less than 10% of all plastic is recycled, so the majority persists on our planet. Much of it ends up in airless landfills, destined to linger for hundreds or even thousands of years, but a massive amount escapes our waste systems, permeates the soil, flows continually down into our waterways and ends up in the oceans. A nanobiological reactor is the initial part of the system in which a novel enzyme stabilization technique is used on the Saccharomyces cerevisiae yeast, as well as iron oxide nanoparticles and carbon nanotubes to convert plastic waste into monomers. In a buffer environment with controlled temperature, plastics are degraded by enzymes. It is a device that uses unique enzymes. Moreover, its maximum efficiency was recorded at a temperature of 50 degrees Celsius.
Increased urbanization and industrialization have led to large amounts of toxic contaminants being released into the environment worldwide. Some of these contaminants occur naturally, but anthropogenic sources, especially mining activities, have contributed significantly to their increase. Mining, mineral processing, and metallurgical extraction are the three principal activities of gold mining industries which produce wastes. Large quantities of waste are produced during this activity, particularly in gold mines, which release over 99% of extracted ore as waste to the environment. A fermentation reactor is designed that uses newly identified bacterial isolates of Cupriavitis metalliterans strain H. Milani to convert toxin gold solution into gold particles, which are inert and visible to the naked eye. The gold can then be separated. This system generates nanogold as a result. Through the use of multipurpose reactors, we were able to produce various products in the fields of industry, medicine, and aerospace. Milanix biogold nanoparticles were used as an X-ray contrast agent, due to exhibiting a high X-ray attenuation, non-toxicity and facile synthesis and surface functionalization for colloidal stability and targeted delivery. Potential diagnostic applications include blood pool imaging, passive targeting and active targeting, where actively targeted Milanix biogold nanoparticles could enable molecular imaging by computed tomography. A new method of cancer treatment, using gold-coated silica nanoparticles, could help patients against the side effects of chemotherapy and radiation. Milanix biogold nanoparticles allow us to control their size, so we can tune the particles to absorb light from infrared lasers and destroy a tumor. Milanix biogold nanoparticles are resistant to moisture and acid. It also will not oxidize, even with prolonged exposure to liquids. Gold's corrosion resistance makes it ideal for the high degrees of sterility required for medical instruments.
The high density of gold makes it opaque to X-rays. It comprises a Milanix BioGold nanoparticles coating with the least wear property, which is 30% lesser than regular copper, the hardest surface, 2 times stronger than other prostheses without coating. It is a ray of hope for young and old patients who want to enjoy an active, long-term and quality performance. One of the strategies to improve the therapeutic mechanism of HIFU is to use ultrasound absorption agents during the treatment. The Milanix BioGold nanoparticles can act as ultrasound absorption agents to enhance the HIFU thermal ablation when the BioGold nanoparticles were injected locally to the focal region, and to examine the dose effects of BioGold nanoparticles on both heating and cooling mechanisms of HIFU. The results suggest that both heating and cooling rates of HIFU procedure could be greatly improved by injecting BioGold nanoparticles, which demonstrates the feasibility of using BioGold nanoparticles to reduce the level of ultrasonic power from extracorporeal source for HIFU treatment. Obesity is a global health threat and requires urgent attention to reverse the disease and prevent its progression to other chronic diseases. Nanotechnology also improved the pharmacokinetics of anti-obesity drugs. Milanix BioGold nanoparticles was used as a serum of hyaluronic acid gold in fractional CO2 laser to treat skin scars. Milanix BioGold nanoparticles was used as an anti-inflammatory serum in laser hair removal. Treatments of neurological diseases and the realization of brain-computer interfaces require ultra-small electrodes, which are invisible to resident immune cells. Functional electrodes smaller than 15 are impossible to produce with traditional materials due to high interfacial impedance at the characteristic frequency of neural activity and insufficient charge storage capacity. The problem can be resolved by using Milanix BioGold nanoparticles. Prototypes of microelectrodes could be made using traditional photolithography. Integration of unique nanocomposite materials with microfabrication techniques opens the door for the practical realization of the ultra-small implantable electrodes. Further improvement of electrical properties is expected when using special shapes of gold nanoparticles. Gold is also used by NASA in the construction of spacesuits. Because of its excellent ability to reflect infrared light while letting in visible light, astronauts' visors have a thin layer of gold on them to protect their eyes from unfiltered sunlight. Because the gold is an excellent reflector of infrared light, it is a critical component of an exciting new space telescope set. Therefore, Milanix BioGold is a new source of this valuable metal. In outer space, radiation from the sun transfers heat directly into objects, much like a microwave, so insulation is not the best option. Coating instruments with Milanix BioGold reflect heat without creating a glare and keeping them cool. Human societies have considered gold production throughout history because of the high value of this precious metal, but despite its widespread use, its production is associated with many pollutions. Gold is sometimes associated with this elements as is sodium cyanide or mercury. A small amount of cyanide can kill any animal. Gold and cyanide have leaked out in both developed and developing countries, polluting rivers and killing aquatic life. Scientists consider these events to be widespread environmental catastrophes. If mercury is used to make gold, even small amounts of mercury compounds can reach the water and cause widespread pollution. Mercury enters the human food cycle in this way through seafood and fish in the form of methylmercury. Mercury poisoning causes disability or decreased efficiency without treatment of the human brain. 30 tons of ore can be wasted in a ring. Gold ore wastes are the source of many heavy elements such as cadmium, lead, zinc, copper, arsenic, selenium and mercury. If these elements have a concentration of more than 1 ppm in water, that water will not be suitable for human consumption. Gold ore wastes are considered as long-term hazardous wastes along with nuclear waste. Also, the industry of extracting gold from its ore is very energy intensive, 25 kWh of electricity for 1 gram of gold produced. By designing and building the state-of-the-art Milanix reactor system, we were able to extract gold biologically from Cupriavitas metalliferous H. Milani biologically for the first time in the world in 32 hours. We were also able to prevent biological gold in important diagnostic and therapeutic dimensions of industrial medicine and aerospace products for the first time in the world.
Among the important features of this system are the following: high decomposition rate of different types of plastics, more efficiency, no need for a sterile system, and the ability to reuse the enzyme system is another benefit of this plan.